Hello, this is Mr. Collier, and today we're looking at using our GDC to do some calculations with the normal distribution. Okay, so we're going to take a look at this first question here, which states a normally distributed variable x has a mean equal to 100 and a standard deviation equal to 15. Find these probabilities. Okay, so for part A, I'm going to find the probability that x is between 90 and 120. Alright, so we can do this without the graphing calculator if this was like 85 and 115, because those are exactly one standard deviation below and one standard deviation above. But we can calculate any probabilities using our graphing calculator. Go to distribution. So you see distribution here right above the variable button. So I click second function and distribution. We need to go to don't forget don't use the first one. You have to use the second one, normal cumulative distribution. Okay. So the second one here, and then we click enter, and then we type in four things. All right. So I've got the four things listed here: lower limit, upper limit, mean, and standard deviation. So the lower limit is 90. I'm going to do comma 120. So lower limit, upper limit. Then the mean, which is 100. And the standard deviation is 15. And it does the calculations for us. It's 65.6%. 65.6%. And next one, we're going to work out the probability of the variable being greater than 130. Okay, so to do this problem, probability greater than 130, we need to type in the minimum, which is 130 here. Yeah, actually, let me just redo the whole thing. Okay, next to get the probability of greater than 130, we're going to do, again, second function distribution, normal cumulative, and the lower bound is 130, and the upper bound is infinity, so we want to make a really big number here, so let's do like 99 to the power of 99. That's a huge number. And oops, let me delete those. We don't want the comma up there. Alright, I just want to press over on my arrow button, then the comma. And you could just type in 9,999 here or something, just something really large. And then the mean and the standard deviation again, so 100. Okay, comma 15. So I've got all that in there. Press enter, and let me see. Actually, 10 to the power 99 is too big. Sorry, 99 to the power 99 is too big. So let's try 10 to the power of 99. Let's try that again. Okay, so that worked, and it's actually 2.28%. 2.28%. So this is 2.28% chance. Okay, now the part C, probability x is less than 80, and we're going to do that on the calculator again. So I'm going to go second function entry to get that to pop up again, and this time less than 80, so we want the upper bound here to be 80, and delete that. Delete the thingy as well. Okay, there we go. And we'll go from 0 here. So alright, so that should work, and I'll press enter, and I get 9.12%. This is 9.12%. Yeah, let's try another example. Here's the age of graduate students in engineering program throughout the U.S. is normally distributed. There's the mean, there's the standard deviation. What's the probability? So part A, the probability that they are younger than 26 years old. That age is less than 26. Alright, so we're going to type this information on our calculator here. So younger than 26. Second function, distribution. Remember the second normal distribution. And the lower limit is 0. Upper is 26. And the mean is 24.5. And the standard deviation is 2.5. Okay, then enter. And I get 72.6%. So that is 72.6%. Okay, part B, what proportion of students are greater or older than 23.7 years old? Alright, so again, second function, entry, and I'm going to just change those first two numbers. Greater than 23.7. So for this one, I want a large number. Maybe I'll do 99. Okay, that's more than 3 standard deviations above the mean, so that should be okay. And this needs to be 23.7, so insert 23.7. Delete that 0, I don't need that. Okay, enter. And it's 62.6%. Okay, let's do part C. Probability the age is between 22 and 28 years old. Okay, so I'll do that again and just change these numbers again to 22 and 28. Press enter and I get 76.1%. Part D, what percentage of ages fall within 1 standard deviation of the mean? Okay, so that's actually pretty easy. 1 standard deviation of the mean by, you should know your normal distribution, that's always going to be 68%. Okay, so this probability, let's write it down, 1 standard deviation is 2.5, so probability from so 22 years of age to 27 years of age should be 68%. Okay, another example. Lifetime of a light bulb is normally distributed with a mean of 2,800 hours and a standard deviation of 450. So part A, find the percentage of light bulbs that have a lifetime of less than 1950. So we're going to do the normal distribution, second function, and second one, of course. Okay, so less than 1950 hours. So I'm going to go from 0 to 1900. The mean is 2,800 hours. And the standard deviation is 450. Okay. So that probability is 2.28%. Okay, so that's 2.28% is the probability. Probability that, I don't know, time about t is less than 1950. Alright. Next, part B. find the probabilities between those hours. These are pretty much the same thing over and over again. I'm just going to show part D. So part D, find the expected number of light bulbs with a lifetime less than 2,000. So I'm going to use the same thing I did before. I'm going to change that value to 2,000. Okay, that's 2,000, and press enter. So that's now that's 3.77%. So probability less than 2,000 is about 3.77%. Okay, so I need to do 3.77% of 120 light bulbs in order to get the expected number of light bulbs with this lifetime. Okay, so I'm actually going to use that number that's on my calculator right now and multiply by 120, and I get 4.53. So that's 4.53 light bulbs. Okay, so you could say about 4 or 5 light bulbs.